Thank you for handling all this. Yes, I'll see.
So basically what we're trying to do is we're trying to create the surfaces for adhesion. I have showcased two ways. One is from the surface menu itself. two options. One is an elliptical patch, the other is the freeform patch. For freeform patch, it's like a freehand drawing or a freehand curve that you draw around the surface that you want to create. Elliptical patch is more defined. Basically, by left clicking and dragging the circle or dragging the ellipse, as the name suggests, elliptical patch, anything within the ellipse shall be encompassed in the surface. So this function is still running. Yeah. So if you see, the surface that has been created after elliptical patch, has taken a nice round contour of the ellipse that we had drawn. Right. Now, what if I wanted a surface from curve? So you first go to curve, create curve. This time we'll have to use a attached curve. So I'm going to select my curve creation method as smooth curve, and my options of attract and attach should be there, right? Because a curve can be, because a surface can be only created from attached curves. So I'm just going to trace the curve around the tooth. Right. So as you keep clicking on points, you can see a red primitive or a red line being formed. That's basically the path of your curve that you're tracing. Right. I'm just going to show it superficially so that we just understand the concept of surface creation. And try to keep your last point of the curve very near to your initiating point so that you can close the curve easily. To split the surface using curve, it's essential that your curve should be one attached to the part, and second, it has to be a closed curve, right? So now that I've drawn my curve, I'm going to close it. So the close curve option, so I've ended my curve near to my origin, point of origin. Now what I'm going to do is I'm now going to close the curve. So go to curve, there is an option of close curve. Your entity will be the curve that you want to close and apply. So you see the software has closed the curve for you, right? So before I split the surface, I would want you to notice how the surface has been split into different parts here. Filter surface. So this is your first surface, this is your second surface, right? Now let's observe what happens when I split the surface using this curve. So I'm going to go to curve and select the operation split surfaces by curves, right? Here my entity has to be my part, right? And either I have two options. It is either all curves or selection of curves. Since there's only one curve, I'm going to go with selection of curve and give the curve as my input and click apply. Now what will happen is, using the curve, we have further divided the two surfaces into four different surfaces. So I'm going to escape from the function and show you how we have split the initial surfaces further. Right? Filter surface. Now you see the surface have been further subdivided as per the curve. Now what I'm going to do is, I'm going to select all these surfaces and separate it to a new part. So separate, right click, separate, copy to part, create new. So always do copy to part rather than move to part, because what move to part function does it removes the surface from your original and then creates a new part. So I've separated the surfaces required. So now that I've done this, I've just made a rough surface. I need to now refine this surface so that I can give it a thickness and connect it to my slot. So I'm now going to do the refining. I am going to hide this part, right? This is the surface that you have received. Some section from the other tools have also come in. So what I'm going to do is, I'm just going to hide my slot, and now I'm going to refine this. But before I refine, what I'm going to do is, I'm going to first merge all these surfaces as one common single surface. So for that, what you can do is, in the object tree, right? In the object tree, you can click on the drop down, new surface, and select all the surfaces and just right click and merge. So if I see, there's a small hole here, right? So there are two options of doing this. Either I can go to fix and fill hole, or there's another option in fix called as stitch. So such small holes, if you see, it's a very minute hole. Such small holes can be fixed with the operation of stitch. I'm going to select my entity. I'm going to write this as extension surface. Surface, right? And I'm going to apply. Now you see that hole is being fixed for you, right? I'm just going to refine this surface into a very nice smooth curvature, and we don't have to necessarily inculcate so much of the surface of the bone. We just want something as a resting piece. So I'm going to use freeform patch. Extension surface is going to be my entity, and I'm just create a smooth output. I'm going to now filter surface, delete these excess surfaces. So if I'm seeing, we have created sharp edges, which is not ideal for fitment in the patient. So we'll have to smoothen this or round the edges. So for that, again, I'm going to use freeform patch and as per my knowledge, just smoothen or round the curvature. So my entities extension, this is my visible part. Will not come correctly. Further try and smoothen it. Seems okay to me. So I'm going to filter. This seems a much rounded surface for attachment. Similarly, we're going to do that at all the edges. Try and smoothen. But what I observe is I've created a noise shell here while deleting the surface. So I'm just going to mark our main shell, invert the marking, and delete the noise shell that I'd created. Again, go back to surface and refine my surface. Right. Similarly, I'm going to try and refine now. This seems better to me. So now we have created a base. It's time we give it thickness. So again, before giving thickness, I'm going to duplicate this. Right. Design, offset. Offset is what we use to give thickness. I'm going to use uniform offset and change this to 0.6. So yes, the thickness is too high. We just require a very small thickness for this. So maybe 1.25 should be sufficient. Yeah, this seems better. I'm going to rename this as now we have created a extension surface. We have created a slot. What I would want you to notice is we had just trimmed the lower section of the slot, which was something like this, which was earlier like this, right? We have to now subtract the component from the bone. So if we were to see the bone and transparent the bone and visualize, the slot is going through and through this through and through the bone. So basically we'll have to subtract the slot from the bone, but we are going to do it after we attach it to our extension surface, right? Now to attach it to the extension surface, you can use two options. Either you can just create a connecting cylinder between the two, or you can use something called as a cylindrical loft. Cylindrical loft is basically a fancier version of creating a link between two different components. So let me show you both the way. The first thing that we're going to do is we're going to create a cylinder between the two. Right, so it is passing through and through the bone, which we will delete later. But before that, let's start creating the connection. Now what we have done is we have created two individual components, the extension surface and bone duplicate, and we have to now create a connection between them or give a connector between them, right? So the first option is you can go to design and create a primitive between the two. So I'm going to create a cylinder, 2 points again. This time I'm going to keep it as 1.1, just a little thicker. So let my point 1 be at this edge on triangle surface, and let my point 2 be somewhere here. So you see, we've created a cylinder. But since our extend length is 10 mm, it is extending 10 mm both from the point 1 and point 2. I'm going to reduce this to 1. I hope you understand the difference that you observe. What I also observe is that the dia that we have set, the radius that we have set is quite high. So I'm going to do it 0.75. Yes, this seems much better, right? Now I'm going to click apply. We have to still set this cylinder slightly. So I'm going to use the align option. The connection at the slot seems okay to me. So I'm just going to keep that as my center of rotation. And move the cylinder slightly inward so that the extra surface that we're seeing outside gets merged with the surface. Yeah, this seems okay to me as a connection. Right? Now coming to surface loft, sweep loft. Suppose you want to create just a different looking contour. So for that, you need to create a path. You just need to give a curve. So what I'm going to do is I'm going to hide all my different components. And assuming that this is my guiding path between for the connection between the two, I'm going to create a curve. I'm going to create a free curve. So it starts from somewhere here and ends somewhere here. Right. So now we have a path, a circular path ready. Now I'm going to go to design, circular sweep, and it will just create a guided cylinder between the two. Now, of course, we can adjust the dia, right? We can make changes like round the endpoints or both. So when you select round, basically it covers, and I'm going to click apply. And so and now we're going to have section, our guiding slot, and I'm going to hide the cylinder. So basically, this is what your sweep looks like. Since it's a smaller distance, you can't visually see much of a change, but sweep works for good long distance guides that we create for, say, femur or fibula guides, wherein we have to create two different, one for the proximal, one for the distal, and you want to give a connection between the proximal and distal ends. Therein you can see a great difference using a cylinder and in comparison to using a circular sweep. So two options, one is just the casual cylinder, the other is circular sweep. And just in case you do not want to use the cylinder as your guiding curve, you can also just create a random curve in between your two components, and you can use that curve as well to create your sweep. So this is something like, I'm going to Boolean union all these components first. So just hiding all the sweep parts, deleting that, right? I'm just going to empty this curve also because that's not required. Now I'm just going to union the cylinder with everything, right? What I'm noticing is the cylinder is just penetrating slightly into the slot. So in case I do not I want to avoid this, there's another trick called as local boolean. So instead of doing a boolean union that we generally do from the design menu, I'm going to today use something called as local boolean. What local boolean allows is, it allows you to unite a part to a surface. So basically my entity is the cylinder 2, I've chosen the complete part, but in my entity 2 what I'm going to do is I'm going to filter and select just the surface, right? Likewise, again here internally what I'm seeing, it's selected, it's going penetrating slightly inward, which I don't want. I don't want to see the protrusion. So again, I'm going to select the surface. So my entity 1 is a complete part and my entity 2 are just surfaces. Not necessary that entity 1 has to always be part and entity 2 surfaces. It can be vice versa. The selection doesn't, it's irrespective of which component you assign as which entity, right? I'm going to create a new part and I'm going to create apply. Now what I'm going to do is I'm hiding all the original parts. I want you to observe is this. The extension that we would have had if we had done the normal union is not visible here. So local boolean helps you to merge parts to surfaces basically, right? So now we are ready. Now our final step will be to subtract our entire component from the bone. That is, one, to give it clearance at the extension level, and two, to just cut the bone or cut the extended slot that we have. So I'm going to use Alt B, that's a shortcut for Boolean subtraction. My entity is going to be local Boolean result, and my subtraction entity will be my bone, right? I'm going to use a clearance of 0.1 and click apply. This might take a little long. still the function is happening. I just wanted to know for space maintainer, I have not received any scan, but if I can just show you on this scan itself that how you can create a space maintainer, will that work?
Yes, yes. I think you can show on the scan you have.
Yeah, that's what. So I'll
Uh,
just do that.
it will be. I think it will be similar to how we are designing the surgical guide.
Yes, exactly.
Exactly.
Exactly. So, but I'll just show you a very basic idea of how you can do. You can just extract two surfaces and create rods in between them. So just I had
Yes,
created a
yes.
connection between these two. You can similarly do
Correct.
that.
Yeah, yeah.
So the reason why this is taking so long is I did not fix the bone before doing the Boolean subtraction, and that's the reason there might be a lot of unfixed entities or noise shells and intersecting triangles already present in the bone, right? Because of which there is a lag in the software, due to which it's taking so much time. So always first step is when you first import all your components from Mimix to 3matic is to fix the files. what I've done is I have just started another project. Till this is happening, till this operation is happening, what we'll do is we'll start that project and we can see the output once the operation is completed in the other window. Change. I'm switching my screens. Right. So the space maintainer is very similar to what we are doing right now. I'll just show you how we can do that. Yeah. So let's assume that we want to create a space maintainer for the tooth we had created, for the surface that we had already created. And for the incisor maybe, right? So I'm going to use this surface, and again I'm going to just create another surface so that we can make a space maintainer for this incisor tooth. So again I'm just going to use surface, freeform surface this time. Create a surface here in between. So the meeting might just end right now. We can all rejoin in like 1 minute because it shows less than a minute. So I'll just end and we can then restart the space maintainer altogether.